So now let us look at some questions which are more involved. So one of the type of question is binomial inside binomial. So now in this question you are asked to find sigma r is equal to 0 to n plus r cn. That is, so I am trying to expand this sigma. First r is equal to 0, you get ncn plus n plus 1 cn plus n plus 2 cn. So here r is increasing. So n plus 3 cn plus so on up to n plus n cn. Now you are asked to find the summation of all these terms ncn plus n plus 1 cn plus n plus 2 cn plus so on up to n plus n cn. The nature of this sequence is that the lower suffixes are same, but the preceding prefixes are increasing by 1. So now how do I analyze this? So can you see that ncn is the coefficient of x power n in 1 plus x whole power n? So 1 plus x whole power n in this expansion, the coefficient of x power n is ncn. So what is n plus 1 cn? This is the coefficient of x power n in 1 plus x whole power n plus 1. And this is the coefficient of x power n in 1 plus x whole power n plus 2. And this is the coefficient of x power n in 1 plus x whole power n plus 3. And this is the coefficient of x power n in 1 plus x whole power n plus n, which is 2n. Now if I want the summation of all this, I just have to find the coefficient of x power n in the summation of this. So coefficient of x power n in this summation is nothing but this. So let us try to find the summation. Can you see that this forms a GP? This forms a GP. So the summation of this GP is a into the common ratio is also 1 plus x whole power number of terms, as you can see r is going from 0 to n. So this will be equal to n plus 1 minus 1 by 1 plus x minus 1. So a into r power n minus 1 by r minus 1. So if we cancel this out, that is equal to 1 plus x whole power n into 1 plus x whole power n plus 1 minus 1 by x, that is into x power minus 1. That is nothing but x power minus 1 into 1 plus x whole power 2n plus 1 minus of 1 plus x whole power n. So now I want this summation is nothing but the coefficient of x power n in this. So the coefficient of x power n in this is nothing but the coefficient of x power n plus 1 in this expression, because you have an x power minus 1 outside. So you have to consider the coefficient of x power n plus 1 here. So what is the coefficient of x power n plus 1 in this expression? So this is nothing but 2n plus 1 cn plus 1. So in this expression you have 2n plus 1 cn plus 1 times x power n plus 1 minus. So do you have a coefficient of x power n plus 1 in this? No, because the highest coefficient in this expansion is x power n. So in this expansion you won't get any x power n plus 1 coefficient. So the x power n plus 1 coefficient only occurs in this, and that is equal to 2n plus 1 cn plus 1. So this will be the summation of this. So this is not the only way to do this question. This question we have already done a question like this in our properties of binomial coefficients topic. This is a sequence where the n value is increasing. So we have done this question using the formula NCR plus NCR minus 1 is equal to n plus 1 CR. You can also use this formula and do this question. What we need to do is, we just need to write NCN as n plus 1 C n plus 1. So if I can write NCN is 1, so n plus 1 C n plus 1 is also equal to 1. Then we apply the process which I have already applied in that question, and we can get the answer as 2n plus 1c n plus 1. So this is also a valid process, and this is also a valid process. So now let us look at another question. So now in this question you are asked to prove that C0 times 2n Cn minus C1 times 2n minus 2 Cn plus C2 times 2n minus 4 Cn up to so on is equal to 2 power n. So now how do we go about doing this problem? So first we need to see that 2n Cn is the coefficient of x power n in 1 plus x whole power 2n, and 2n minus 2 Cn is again the coefficient of x power n in 1 plus x whole power 2n minus 2, and 2n minus 4 Cn is the coefficient of x power n in 1 plus x whole power 2n minus 4, so on. Now let us consider an expression C0 into 1 plus x whole power 2n minus C1 times 1 plus x whole power 2n minus 2 plus C2 times 1 plus x whole power 2n minus 4 plus C3 times 1 plus x whole power 2n minus 6, so on, plus minus plus minus. So what can you say about this expression? So if you find the coefficient of x power n in this expansion, that will give you my given expression, because 2n Cn is the coefficient of x power n in this, so into C0. So you get the first term minus C1 into x power n coefficient plus C2 into x power n coefficient, so on. So if you can find the coefficient of x power n in this expression, in this expansion, you get the required expression. But how do you get the coefficient of x power n here? So now let us compare this with our binomial expansion. So this is nothing but C0 into 1 plus x whole square whole power n minus C1 into 1 plus x whole square whole power n minus 1 plus C2 into 1 plus x whole square whole power n minus 2 minus C3 into 1 plus x whole square whole power n minus 3, so on. So if I take 1 plus x whole square as y, so let us consider 1 plus x whole square as y. So is this becoming C0 into y power n minus C1 y power n minus 1 plus C2 y power n minus 2 minus C3 y power n minus 3, so on. So is this equal to y minus 1 whole power n? So what is the expansion of y minus 1 whole power n? nc0 into y power n minus nc1 into y power n minus 1 plus nc2 into y power n minus 2, so on. So that means this expression is equal to, once you back substitute y, you get 1 plus x whole square, this is y, minus 1 whole power n. So this expression is nothing but finally 1 plus x square whole square minus 1 whole power n. So that is nothing but, if you expand this, 1 plus x square plus 2x minus 1 whole power n minus 1 and plus 1 gets cancelled, that is equal to x into x plus 2 whole power n, that is x power n into x plus 2 whole power n, and effectively you want the coefficient of x power n in this expression. So what is the coefficient of x power n in this? So you already have x power n outside, so you need the constant term in this. The constant term is nothing but 2 power n. Hence the coefficient of x power n in this expression, which is same as the coefficient of x power n in this expression, which is same as the given expression, is equal to 2 power